Naive Bayes. Purely a probability-based machine learning algorithm. Naive Bayes uses conditional probability. Conditional probability as its basis. So it's a probability based algorithm, uses conditional probability as its basis. Now you might say, what is conditional probability? Conditional probability is probability of A given B has already occurred is equal to probability of A given B has already occurred is equal to probability of A intersection B, probability of A intersection B divided by probability of B divided by probability of B. Probability of A given B has already occurred. Probability of A given B, the straight line symbol indicates probability of A given B has already occurred is equal to probability of A intersection B divided by probability of B. Or given B has already occurred. One event, the B event has already occurred. What is the probability of A? If B has already occurred. Take for example, you have taken out all the black cards. In the deck of cards, you have already removed the black cards. What is the probability of red being dice? Or the probability of red being, what you call the other one, flower or something like that. So, because you have removed black, right? Event has already occurred. So that we call it as conditional probability. Probability of an event given that the other has already occurred. What happened to this? Just switch off and switch on again. Bayes theorem only. We'll talk about Bayes theorem. Bayes theorem is the extension of conditional probability. Bayes theorem is an extension of conditional probability. Probability of B given A is equal to See, given that you drew a red card, the condition is you have already drawn a card, it is red. What is the probability that it's a 4? So probability of 4 given it is red. So how many red cards will be there? 26. What is the probability of 4? 2 by 26. So you can see here 2 by 26 or 1 by 30. So a condition will be there. That is called conditional probability. So you have already drawn a card. Red card. You have already drawn a red card. What is the probability that it's a 4? 4 and red card. 2 by 26. So 1 by 30. So given that a condition has already occurred. What is the condition that has already occurred here? We have already drawn a red card. What is the probability of being it any number is 2 by 26. 4, 2 red cards will be there. If it is 5, it is also 2 by 26. The probability of the card being any number is 2 by 26. The probability of the cards being any of the alphabets is again 2 by 26. So conditional probability. Conditional probability means the other event has already occurred. In this case, what is the event that has occurred is we have already drawn a red card. Already telling you that it is a red card. What is the probability of that red card being 4? That is called conditional probability. Clear? Conditional probability. And A intersection B means both have to be true. A intersection B means both have to be true. What is A here? 4. What is B here? Red. That means the card must be both 4 and red. Intersection is and. Union is or. The compulsory condition here. The card must be red and also be 4. How many red and 4 cards are there? 2 cards only will be there. So 2 by how many red cards? 26 cards will be red in the deck out of 52 cards. So it will be 2 by 26. So that is the concept of conditional probability. A intersection B means both the conditions have to be met. Both the conditions have to be met. Now this conditional probability is also called as Bayes rule. The conditional probability is also called as Bayes rule because a statistician named Bayes have developed this concept of probability very vastly. Now let us take this rule extension to our analysis. Bayes rule for classification. And mind you, this is only a classification algorithm. You cannot use naive Bayes for regression. Naive Bayes is a purely classification algorithm only. It cannot be used for regression. And it is based on Bayes theorem or Bayes rule, which is the fundamental of probability theory in statistics. So Bayes' rule for classification, if X is independent variable, X is your independent variable, and Y is dependent variable. If X is your independent variable and Y is your dependent variable, now probability of capital X given Y is known from training data. This we will know from training data. Probability of X given Y has already occurred is known from our training data. Now, probability of Y given X is what needs to be predicted. Is what needs to be predicted. The predicted is probability of Y given X has already occurred is your prediction. So probability of X given Y is already known from our training data. We have our historical data. We can calculate the probability of X given Y. What we are trying to predict is probability of Y given the independent variable X. So the formula is extended. Probability of, let me go down. Probability of X given Y is equal to probability of X intersection Y divided by probability of Y divided by probability phi of Y. Now this is what we call it as probability of evidence. Probability of evidence given outcome. Probability of X and Y, only two variables, only one single independent variable. No, there is no variance here. See, we are just talking about variables here. X is an independent variable, Y is a dependent variable, that's all. X is an independent variable, single independent variable, not multiple. It is a single independent variable. Y is your dependent variable. Now, take for example, X can be height of the person. Y can be gender, male or female. Based on a height of the person, you are predicting whether the person is male or female. X is an independent variable. Y is a dependent variable. That's all. There is no variance and all here. So it's a purely the concept of the independent and dependent variable. This is known from training data. Once we do an example, you will understand. So based on this, what will be the formula for probability of Y given X is equal to, it will be the same probability of X intersection Y this will be probability of X. This is what we are. So the probability of outcome given evidence. This is what we are predicted. Probability of outcome given evidence is predicted. All right. Now let us go into the naive Bayes rules of classification. We have talked about the basic Bayes rule. We will go into the naive Bayes rule for classification. There are two different rules. Both of them developed by the same statistician. Naive Bayes rule for classification. Naive Bayes rule for classification. The naive Bayes rule for classification is probability of y given x has occurred is equal to probability of x given y has already occurred multiplied by probability of y divided by probability of x. The naive Bayes rule for classification. Probability of y given x has already occurred is equal to probability of x given y has already occurred multiplied by probability of y divided by probability of x. This is when you have only one single variable in your data. When you have single variable, this is the context. But in real life, we will have multiple variables, right? In real life, we have multiple variables. Naive Bayes rule for multiple independent variables. Multiple independent variables. Naive Bayes rule for multiple independent variables. The probability of y is equal to k. What is k here? K is the level. K is the level in the dependent variable. Level can be 0 or 1. The probability of k is equal to 0 or the probability of k is equal to 1 given x, given x1, x2, x3 till xn is equal to the probability of y is equal to 0 given x1, x2, x3, xn. What is this x2, x3, xn? Independent variables. K is the levels in the dependent variable. The levels in the dependent variable are 0 or 1 for you have yes or no, right? In the dependent variable, 0 being no, 1 being yes. X1, x2, x3 are your independent variables. Now, the calculation goes like this. Probability of x1 given y is equal to k multiplied by probability of x2 given y is equal to k multiplied by probability of x3 given y is equal to k till probability of xn given y is equal to k multiplied by probability of y is equal to k divided by multiple probability of y is equal to k. And the denominator would be probability of x1 into probability of x2 into probability of x3 till into probability of xn. So don't worry about the formulas. Once you do the calculation, you'll understand the exact what we are talking in the formulas. I'll send you there. We'll do 2 examples. Then you will be able to understand what exactly I am talking about. All of you got the formula? Now, what is P here? P represents probability that lies between 0 and 1. The probability between 0 and 1. What is K here? K is the number of classes or levels in dependent variable. If it is a binary variable, there will be 2 levels. If it is multinomial, more than 2 levels. What is x1, x2, x3 till xn? We call them as independent variables. Independent variables. Now, what is y here? Y is the dependent variable. Y is the dependent variable. So this is the breakdown of the formula. So if you are looking at the formula, Bayes rule for classification formula. So this is the basic formula. Probability of C given X. Prior probability, positive. Let's not go into that one because the terminologies are a little bit difficult. Prior probability will be your class probability. Posterior probability is what we are trying to predict. Predictor prior probability will be your denominator and likelihood is your numerator. Likelihood is probability of x1 given C, probability of x2 given C, probability of xn given C into probability of C. Hey, they made a mistake here. This is probability of x given C here, not C given x. Sometimes these guys also make silly mistakes in the formulas. This is also C given X. Correct formula. Another correct formula. Yeah, this formula, but I'm not sure you guys will be able to understand. So put both formulas. This has to be probability of X given C. Okay. So this is a pure, what we call as classification algorithm. This is the email ID, right? So all are covered, na? 10 people. Anybody missing here? 2, 3, 4, 5, 6, 7, 8, 9, 10. Anybody missing? Nobody. Right. So all of you download the sheet. Okay, all of you have downloaded the sheet. Okay, all of you have downloaded. Now, what is the dependent variable here? Stolen. The dependent variable is stolen. How many levels are there? How many cases are there? Two. Yes or no. There are two levels. K is equal to 2 here. Yes and no. No. See, we are trying to predict. The problem statement says predict if the car will be stolen if the color, type and origin is given. Not like that. Problem statement में दिया जाएगा. What are the independent variables? Independent variables are color, type, origin. Color, type and origin are your independent variables. All right. Now, what the algorithm will first do is the step one is create cross tabulations. Create cross tabulations of dependent and independent variable. It will first do a cross tabulation of dependent and independent variable. Okay. Now, let us say we are trying to create the first cross tabulation between stolen, which is yes and no, and the first variable would be red color and yellow color. So we are doing it on color. Cross tabulation of color and stolen. We also need row total for calculating the probability. How many reds are stolen? How many reds are stolen? Reds that are stolen are 1, 2, and 3. 3 reds are stolen. How many reds are not stolen? 1, 2. 2 reds are not stolen. How many yellows are stolen? 1, 2, 2 yellows are stolen, and the remaining 3 are not stolen. So row total will be is equal to this plus this. You can drag it down. Grand total will be is equal to this plus this 10. Okay. Now we'll calculate the cross tabulation for the second variable. You can copy that table down, paste it down, Control V. This time instead of color, we go with type. The red will be changed to sports. SUV. How many sports are stolen? 4 sports are stolen. How many sports are not stolen? 2. How many SUVs are stolen? How many SUVs are not stolen? Sorry, 3, right? Grand total is 10. Control S. Okay, copy this table again. Control C, give 2 rows gap. Control V. This time we will go with origin. Domestic and imported. So how many domestic are stolen? How many domestic are not stolen? How many imported are stolen? How many imported are not stolen? 2. So this is the first step. First step is creating the cross tabulation of the variable so that the probabilities can be calculated. The same process we use in Gini and entropy also, right? Where we convert it into, there the numerical data will be converted into binary. Here it is, we are having luckily classification data, so we are converting it into cross tabulation. Now, the question is, find predicted probability if find the predicted probability if the color of the car is red, if the type is SUV, and if the origin is domestic, whether the car will be stolen or not. So you have to find out whether the car will be stolen or not. If the car will be stolen or not. This is what we have to find out. That means we have to find out basically what probability of yes given it is red, SUV and domestic. To find out probability of yes given it is red, SUV and domestic. So how do we find this? Is equal to probability of red given yes multiplied by probability of SUV given yes multiplied by probability of domestic given yes. We will get a cumulative probability. If the cumulative probability of this is greater than the, so we will get a probability here, right? We also need to calculate the probability of no given red SUV. So probability of red given it is no, probability of SUV given it is no, probability of domestic given it is no. So whichever has the highest probability, then that will be our final prediction. Among these two, whichever has the highest probability, that will be our final prediction. right? Shall we proceed to the calculation? So first we'll calculate this. Probability of red given yes. Probability of red given yes. So how will you calculate? Is equal to hmm? 3 by, how will you calculate? 3 by, no. What is the row total? 5. So 3 by 5. Sorry, column total. Red, no. 0.63 divided by 5. Yeah. Column total. Yeah. That's what I used. Is equal to 3 divided by 5. Then calculate probability of SUV and S. So SUV and S 1 divided by 5. SUV, na? Type is SUV. SUV is how much? How many SUVs are there? One only, right? No. How many are there in S category? SUVs that are stolen. SUV given yes. Total stolen is how many? 5. Total how many are stolen? Stolen, na? Given y is equal to yes. How many yes are there? 5. How many of them are SUVs? 1. So the answer is 0.2. See, first of all, you have to look for categorization of yes. How many yes are there? 5 yes are there, right? Out of those 5 yes, how many are SUV? 1 divided by 5 would be 0.2. Y is equal to yes. We are calculating Y is equal to yes. Yeah, I think I am getting confused here. What is the probability of, sorry, what is the conditional probability formula? Probability of X given, see this conditional probability formula. Conditional probability formula is probability of A intersection B divided by P of B or A, B. Probability of A intersection B divided by B. So red and stolen are 3. What is the probability of B? B is yes, okay. Yes, okay, no problem. So how many domestic are stolen? Is equal to 2 divided by 5, 0.4. Probability of likelihood of evidence. Probability of likelihood of evidence is multiplication of these three, 0.6 into 0.2 into 0.4. So what is the probability of likelihood of evidence? It is multiplication of all three. You get 0.048. Then prior probability of yes. What is the prior probability of yes? How many yes and no are there? 5 by 5, 5 and 5, right? Is equal to 5 divided by 10. I think there are 5 yeses and 5 nos. 1, 2, 3, 4, 5. 5 yes and 5 nos. Then multiplication of these two. There are 5 S's no? And 5 no's. 5 by 10 and 5 by 0.5. Into prior of yes. So is equal to 0.048 into 0.5, 0.024. Done. If you know probability of S, how will you calculate probability of no? 1 minus probability of yes. We don't need to do denominator. It is for both probability S and no, the denominator is same, right? The formula is divided by probability of X into 1, same denominator for both the things. So why do you need to do it again? If you want, you can do it also. But same for this calculation and this calculation, the denominator is common. Right? We don't need to calculate it. So we are calculating probability. No. Because for both the equations, the denominator is common, which is x1 into x2, probability of x1, probability of x2. So is equal to 1 minus 0.6 is equal to 1 minus 0.2 is equal to 1 minus 0.4 is equal to 0.4 into 0.8 into 0.6 is equal to 5 by is equal to 0.5, 0.096. So the probability of the vehicle being stolen if it is red color, SUV and domestic is no. Why? Because the probability of no is higher than probability of yes. What you got? SUV not stolen 3.3 by 5. You got 0.8. SUV S 1 by 5. I made a mistake here. Huh? No, correct only, right? 0.6. Okay, we'll have to calculate freshly, but it's the problem. Red and no. 2 divided by 5, right? This is correct. Is equal to SUV and no. 3 divided by 5, 0.6. Domestic and no. 3 divided by 5, 0.6. 0.144, right? 0.5 and 0.072. Yeah, still it is no only because the probability of no is higher than probability of yes. Yeah. But SUV, how it is not matching? Even I'm thinking that. Rest of all are coming correct, right? SUV is the problem. Still not matching. Why we are getting this difference?
We have to verify total.
Yeah, that's column total. No, no, the formula I'm missing somewhere. Conditional probability, the formula is, it is probability of D, not probability of A. This probability of D. That means you have to take row total only. So we have to take row total only. Is equal to.
B is yes or no. So B is yes or no. So yes total and
No, no, no. Probability of B will be what? In our case, B is. No, no. B is our categorization. We are looking at categorization, right? We are looking at wrong formula actually. See here. That's what I'm thinking where I'm missing out. If you look at the multiple thing, probability of x1, y is equal to k. That given it's the y is equal to k. That means you have to take the row only. It has to be row only, not column. It has to be row only. So is equal to 3 divided by 5 is equal to 1 divided by 4, right? Is equal to 2 divided by 5. Right? 0.03. Yeah? Got it? Now is equal to 1 minus 0.6 is equal to 1 minus 0.25 is equal to 1 minus 0.4. 0.09. Yeah, now we are matching, now we are getting is equal to 1. So we have to take its row totals only, not column totals. All right, got it, all of you? So we will take a break for 15 minutes and then we'll come and work on the second problem also. Okay. Online guys, we'll take a break for 15 minutes and then come back. All right. Okay. So for this example, we will first calculate class prior probabilities. So class prior probabilities. So we have to calculate probability of y is equal to banana, probability of y is equal to orange, probability of y is equal to other. So here the dependent variable is what? The fruit type. The dependent variable is type, which has how many levels? 3 levels: banana, orange, and other. There are 3 levels. Earlier we were doing binary problem. Here it is a multinomial problem because we have more than 2. More than 2 levels are there. So this is a multinomial problem. Now what are the independent variables here? Independent variables are the features of the fruit: long, sweet, the taste of the fruit, and the color of the fruit. Long, sweet, and yellow. The 3 independent variables are long, sweet, and yellow. So we using these 3 variables, independent variables, we have to predict the type of the fruit. So first calculate the class prior probabilities. Total how many bananas are there in our data? 500. Total data is 1000. So is equal to 500 divided by 1000. You got 0.5. How many oranges total? 300 divided by 1000, 0.3. Other types of fruits are 200 divided by total size 1000. So these are our class prior probabilities. Okay. Now you have to find the probability the fruit the fruit type is banana if it is long, sweet, and yellow. So we have to find the probability of the fruit type is banana if it is long, sweet, and yellow. So that means we have to calculate three probabilities. The first one is probability of it being banana if it is long, sweet, yellow. Similarly, we also need to find the probability of the fruit being orange if it is long, sweet, and yellow. And we also need to find the probability of the fruit being other if it is long, sweet, and yellow. And whichever has the highest probability, that will be the categorization. Okay, all right. So first we will calculate the probability of likelihood of evidence of the first case. The probability of x1 is equal to long given it is banana. The probability of x1 is equal to long given it is a banana. So how many bananas are long? 400. What is the total number of bananas? Divided by 500. So 400 divided by 500. Probability of x2 is equal to sweet given it is banana. So how many bananas are sweet? 350 is equal to 350 divided by total number of bananas is 500. 0.7. 350 divided by 500. The probability of X3 is equal to yellow, given it is banana. So how many how many bananas are yellow? 450. 450 divided by total number of bananas is 500. So 450 divided by 500. Now probability of likelihood of evidence. Probability of likelihood of evidence is multiplication of these three, 0.8 into 0.7 into 0.9, 0.504. Prior probability y is equal to banana, we have already calculated, which is 0.5. So multiplication of these two, the probability of banana being long, sweet, and yellow is equal to probability of likelihood of evidence multiplied by prior probability of banana. So is equal to this into this, 0.252. So this is 0.8 into 0.9 into 0.7 into 0.9. And this is the multiplication of these two. Now we have to calculate probability of long, given it is orange, probability of sweet, given it is orange, probability of yellow, given it is orange, probability of y is equal to orange. Probability of, or hello, yeah, you're calling from where? Yeah, tell me. but it was rejected. Yeah. Now, probability of long and orange. Once you're done, please confirm. Where? This one. This one is here only, no? We calculated here. 500 fruits are there, no? Banana. 500 by 1000, 300 by 1000, 200 by 1000, 5, 3, and 2. That's what we have copied from here. See here. I just taken it from there. So the thing is, sorry, is equal to 0 divided by, how many oranges are there total? 300. This will become 0. Now, when one of the probabilities becomes 0, the whole calculation will become 0. So, to avoid this situation, there is something called Laplace correction. Laplace correction is implemented when one of the probability becomes 0. So when one of the probability becomes 0, we Laplace suggested to replace 0 with a smaller value closer to 0 and continue calculation. So we will, real-time scenario, we will see this scenario where you will get 0 probability. When you get this 0 probability, what Laplace is a statistician who suggested is, you replace that 0 with a smaller value closer to 0 and continue calculation. So we got long and orange as 0. I am converting it to 0.10, a smaller value closer to 0, so that the calculation does not become 0. This we call it as Laplace correction. Now the Laplace correction, the smaller value must be between 0 and 1, closer to 0, as much as possible closer to 0. That we call it as Laplace correction. Laplace correction is a correction used when probability becomes 0. Replace 0 with a smaller value closer to 0. Your choice, anything, but it has to be a smaller value closer to 0, and it must be between 0 and 1. So based on that, we have converted 0 to 0.1. How many oranges are sweet? 150, right? 150 divided by 300. So we have done Laplace correction for our understanding why we have done it is Laplace correction. How many yellows are orange? 300, right? Is equal to 300 divided by 300. So likelihood is 0.1 into 0.5 into 1. Probability of likelihood orange is 0.3. Is equal to 0.05 into 0.3, 0.05. 0.15. Now calculate for long and other, sweet and other, yellow and other, probability of other, and probability of other. Done, long and other. So how many longs are other is equal to 100 divided by 200. How many sweet are other? 150 divided by 200. How many yellow are other? Is equal to 50 by 200 equal to 0.5 into 0.75 into 0.25 is equal to 0.2 equal to 0.1875, right? So what is the final probability? The largest probability is this. So the categorization is banana. Yeah. It's for understanding, because what happens is when you're trying to do neighbors, when you're dealing with multinomial classification problems, if a particular class is not fitting, that particular class accuracies are being fallen, then you have to go back and check for where the you will get the cross tabulations in the output. You have to go and check those cross tabulations. Sometimes you have to play with the Laplace value adjustment also. By default, I think it takes as 0.5 or 0.6. You have to sometimes reduce the Laplace to closer to 0. And then you try to adjust the class probabilities. See, these are all for you to explain to the recruiter. See, every recruiter will ask you which algorithm you know, explain me in simplistic terms. It's your choice. Other than, I told you now, multiple linear and binary logistic are compulsory. Apart from this, they will ask you any other algorithm. You can choose any other algorithm. Sometimes they will only ask you, do you know naive-Bayes? Because naive-Bayes is used in sentimental analysis, particularly in text, natural language processing. You use naive-Bayes a lot. So they may ask you about naive-Bayes algorithm, what is conditional probability, what is this thing. So basic formulas they'll ask you, what is Bayes rule of classification, simple things they will ask you. If you are looking at NLP, naive-Bayes is compulsory. So these things are help you to explain. Once you do the calculation, you have to explain. So not that you should be telling you, if you are not comfortable with neighbors, stick to another algorithm like decision tree, or we will have simpler algorithm like k-nearest neighbors, KNN, which is a simple algorithm to explain based on distance. So you have to do that. So basically, that's what they're asking. Last week, some of the PG20 guys gave interviews. Everything was based on what they were working on in GitHub, which algorithm by have they implemented. They asked them to explain them the algorithm background. So if you are interested in AMS, if you see the more complicated algorithms to explain, the chances of your recruitment are high. If you want to distinguish yourself from the rest of the people, you need to have that slide deck. So if you explain to them neighbors algorithm in 5 minutes or 2 minutes, they will definitely look at your profile in a different manner, because neighbors is a complicated algorithm compared to the simple algorithms. Hello? Yeah? Yes? Yes, sir. Good morning. Tell me. Yeah. Yeah. No, I'm in a class right now. I didn't check my email. Around 1 o'clock. Yeah. The question itself mentioned that we need a fruit and banana. Why did we do orange? Because how will you know that it is the highest probability? You have to do comparative, right?
So, but why do we need the highest?
Because if it is long, sweet, and yellow, the probability of banana is the highest. So then we can say it is the fruit is banana. Type has 3 classes. How will you predict 3 classes? You have to calculate probabilities for all three classes, and then whichever class has the highest probability, that will be your prediction. Even in logistic regression, we have yes or no. The algorithm calculates probability for yes and probability of no. Whichever has the probability, that will do. In the backend, it will calculate all the class probabilities. That is part of the algorithms. Not that we will calculate only probability of yes. Probability of no also has to be calculated. Then only we will know what is. So suppose a lot of people say, sir, if the probability of S is 0.70, it's obvious. Why do you need to calculate probability of no? That's the problem. That is the part of your algorithm process. The statistic says you have to calculate both probabilities, compare both the probabilities, and come up with the highest probability. Here we have three classes. So we have to calculate all the three probabilities, and then whichever is the class that has the highest probability will be the final probability. If you have 10 levels, 10 probabilities will be calculated.
So like if orange had the highest probability,
Then we'll take orange as the fruit. No, 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 no. If it is, then we will say no to banana. Then we will say it is not banana, it is orange. Then it will say no, it is not banana. It can be either orange or it can be either other. Now what it means based on again probability. If it is orange, it will finalize it as orange. But technically it will say no to banana. Got it? So I'll send a data set which is very small. We have to just do label encoding and let us run this naive algorithm. We need to have a classification data set which is smaller. Without missing values, I'll send. I think we worked on telecom churn, right? Where we work, we didn't work on it here. Melbourne regression, smart decision tree. We have done the telecom churn. For decision tree and NM forest, we have done. XG boost and all, right? So we have not done the HR attrition. So I've sent you the data set. check the data, the data types, variables. You have to label and code some variables. So the attrition is the dependent variable. Attrition is a dependent variable, which is in the form of yes or no. Attrition is the dependent variable, which is in the form of yes or no. Now, there might be single value columns. Just check them. There are no missing values. There are no missing values. You can't do get them this because the number of rows are less. You have to learn them. Space. So you are done. All of you have inputted the data. Now, let us split the data into numeric and numeric columns is equal to attrition dot select underscore d types include is equal to np dot number. Object call is equal to attrition dot select underscore d types include is equal to square bracket single quote object. So we have separated the data into numeric calls and object calls. So split data into numeric and object variables. Split data into numeric and object variables. All right, all of us split the data into numeric and object variables. It will take both int 64 and float 64. There is a that will go into object. Now we have to separate them. In the numeric data, whichever is categorical, we have to separate them. Govind, chapandi. Sir, right, okay. Pakistan. Okay. So numeric columns dot columns. Yeah. Numeric columns dot columns. So we have some categorical variables in our data, right? So we have to identify them. So age is numerical, no doubt about it. Daily rate, numerical, no doubt about it. Distance from home, numerical. Now education is categorical. So we have to identify categorical calls. Categorical calls, or we'll write it in below. Categorical columns in numeric columns would be, first one would be education, Then next one would be employee count. It is numerical only. Employee number, we will anyway delete it because that's too many numbers. Environment satisfaction. Categorical, right? Level will be there. Environment satisfaction. We will delete them. We'll look at it. Hourly rate, numerical. Job involvement, I think is categorical. Job level is categorical. Job satisfaction is categorical. Then monthly income is numerical. Monthly rate is numerical. Number of companies work, person salary hike, performance rate, relationship satisfaction, both are categorical. Standard hours, numerical. Stock option level, categorical. Then total working years, training time last year, work-life balance, I think it is categorical. Years at company, years in, or I think the rest of all are numerical only, right? Now, to make sure whether these are really categorical or not, we have to check. We are assuming that these are categorical, but we need to check whether they're actually categorical or not. So how do we check? We'll create a list. Cat calls is equal to square bracket, and you copy all these variables and you remove the hashtags. Environment, education, single quote. So we like a simple rule. For call in cat calls colon numeric, frequency is equal to numeric calls column square bracket call dot value underscore counts print frequency. So the loop will take in each iteration the call value, first iteration education, second iteration environment satisfaction. It will take these things and then we can check whether they are actually numerical or categorical. Just a second, let me just scroll down once. 1, 2, 3, 4, 5, 1, 2, 3, 4. Job satisfaction 1, 2, 3, 4, 0, 1, 2. All are categorical only, right? All are categorical in nature. Call will take the shape. So it's like X. You are giving it as for X or for call. So call value will take the value of the list in each iteration, the call value in the first iteration for education in cat calls. Numeric call square bracket education dot value counts. In the second iteration for environment satisfaction, numeric column, square bracket, environment set. So the call value will take the value of the list value in each iteration. So it can be for call or it can be for X. For loop command. For X, you can give for any alphabet. You can give any alphabet for X in call, for Y in call, or for Z or anything. The call value will change in each iteration. It will be based on the previous list. That is what we are getting as the output. గోవింద్ నా ప్రొఫైల్ ఉంది మీ దాంట్లో ఎస్ఏపి ఐడి కూడా ఉంది నాకు ఓకే అన్నీ ఉన్నాయి యాక్చువల్గా మీకు కంప్లీట్ నాది ఎన్ఎంఎంఎస్లో అన్నిట్లో ఉంది గ్లోబల్లో ఉంది ఎన్ఎంఎంఎస్ బాంబేలో ఉంది ఎన్ఎంఎస్ హైదరాబాద్ అన్నిట్లో నా ప్రొఫైల్ ఉంది విఎఫ్ ప్రొఫైల్ అది కోర్ దాంట్లోనే ఉంది ఎస్ఏపి ఐడి కూడా ఉంది కావాలంటే మీకు ఎస్ఏపి ఐడి కూడా పంపిస్తాను అన్నీ ఉన్నాయి నావి వాళ్ళు గ్లోబల్ వాళ్ళు అట్లాగే తీసుకున్నారు విఎఫ్ ప్రొఫైల్ నాది గ్లోబల్ ఎన్ఎంఎంఎస్ గ్లోబల్ ఉంది కదా గ్లోబల్ యాక్సెస్ ఎడ్యుకేషన్ వైశాలి సోలంకి వీళ్ళందరూ ఉన్నారు కదా వాళ్ళు శాలిని ఆమె వెళ్ళిపోయింది శాలిని వీరమణికాళి విజయభూమి యూనివర్సిటీకి వెళ్ళింది కదా డైరెక్టర్ గ్లోబల్ యాక్సెస్ సో ఆవిడ అందరూ తీసుకున్నారు వాళ్ళు ఓకే మీకు కావాలంటే సాపేటీ కూడా పంపిస్తాను నేను ఓకేనా నా పేమెంట్స్ వస్తున్నాయి గ్లోబల్ నుంచి ఎగ్జిక్యూటివ్ T2 X T2 చెప్తున్నాను గ్లోబల్లో 2 చెప్తున్నాను అప్గ్రేడ్ ప్రోగ్రామ్ కూడా చెప్తున్నాను అదే ఓకే ఓకే నో ప్రాబ్లం ఓకే షూర్ ఓకే షెడ్యూల్స్ ముందు నాకు ఒకసారి చెప్పు షెడ్యూల్స్ ముందు ఒకసారి కాల్ చేయండి ఓకే రైట్ okay all of you check the frequency counts right of all the numeric categorical variables they are all categorical in nature so we will separate them category calls is equal to numeric columns double square brackets copy paste the values double square brackets copy paste the values control C control V then we have to immediately drop them numeric columns is equal to numeric columns dot drop open bracket square bracket control V comma axis is equal to 1 so separate them as category columns and immediately drop them as numeric columns from numeric columns copy paste from the top paste on the loop command only All right, all of you have done the separation of the data. See, we have separated them into new data frame called category calls. We have separated from the numeric columns. Double square bracket means you are subsetting the data frame or slicing the data frame. From numeric columns, we have separated them as categorical columns. And immediately we are dropping them from numeric columns. Otherwise, it will be duplication, right? To avoid duplication, immediately we are dropping them. Here we are selecting them as a separate data frame called category columns. Here we are dropping them from numeric columns so that there is no duplication. So we have identified that these are categorical columns. Double square brackets means you are selecting them as a separate data frame. Immediately you are dropping them from numeric columns to avoid duplication. That is what we are doing here. Not assume, we found out, no? These are the for loop is clearly giving us 1, 2, 3, 4, 5, 1, 2, 3, 4. The categorizations are given, no? There is no assumption here. I ran the for loop to confirm. So they are categories. See, the output is showing it as categories. That's why I separated them as categorical columns, created a new data frame called categorical columns. Then I drop them from numeric columns. Otherwise, it will be duplicate columns, right? To avoid it, we are dropping them. Now do the describe of numeric columns, identify that single value columns. Do the describe of numeric columns. So what are the single value columns? Employee count is single value. Employee number, anyway, we will drop it. It's like ID, employee ID. Hourly rate is not singular. Monthly income, not singular. Monthly rate. Standard hours is again similar. So we have to drop standard hours and employee count. So standard hours and employee count, you have to drop from numeric calls because they are single value columns. You can see from the describe. Hello. ఎక్కడి నుంచి అండి చెప్పండి అది ఆల్రెడీ ఇంతకుముందు రిజెక్ట్ అయింది కదా ఆల్మోస్ట్ 3-4 months అవుతుంది too many obligations same no change BTO ప్రస్తుతానికి ఏమీ లేదమ్మా మీ వాళ్ళు ఎక్కువ అవును చేసినా కూడా మళ్ళీ మీరు మీ దగ్గర ఈఎంఐస్ మొదలవుతాయి కదమ్మా అది ప్రిన్సిపల్ అమౌంట్ ఇవన్నీ కలిపి కొద్ది తర్వాత కాల్ చేయండి అమ్మా 3 o'clock తర్వాత మాట్లాడతాను Okay. So numeric calls is equal to numeric columns dot drop square bracket single quote employee count C capital comma single quote what is the other one standard hours control C control V employee number also yeah thank you you have to drop employee number also right yes it's just like an ID comma access is equal to 1 then object columns dot shape then numeric columns dot shape then category calls dot shape so we have 9 object columns 14 numeric columns 9 categorical columns 32 columns right initially we had how many columns 35 so we have removed 3 columns right so 35 so call in columns column frequency is equal to object columns square bracket calls counts I'm just checking if there are any singular values in object columns see marital status yes marital status is yes oh over 18 we have no also huh? So we have to drop marital status sorry over 18 we have to drop sorry yeah over 18 we have to drop because that's only one category right we have to drop over 18 so just do the object columns frequency also and check All of you do this. Over 18 we have to drop. Okay. So object columns is equal to object columns dot drop single quote over 18, comma axis is equal to 1, right? Now attrition df is equal to pd dot concat object columns, comma category columns, comma numeric columns, comma axis is equal to 1. Okay. Now split it into y and x. Sorry, label and code. Array, yaar. Without doing label and code, we did the concatenation. We have not done label and coding, right?
I observed something like but label and also we get same answer. Okay. So let's say we have this,
Is it in numbers or is it in?
numbers, it's in numbers. Like we have 1, 2, 3, 4 instead of 0, 1, 2, 3.
Okay.
And it still gives the same answer.
Mm-hmm. No, no. If it is numbers, but here we have text, na?
We have text.
Text will not work, right? That is there. Their numbers are there, but here we have text. Text will not work. Text needs to be converted. It still is the same output. Yeah. Okay. So from sklearn.tree processing, import label encoder. LE is equal to label encoder. Object columns dummy is equal to object columns dot apply LE dot fit underscore transform. Category calls dummy is equal to category calls dot apply LE dot fit underscore transform. Now here we have to use object columns dummy, category columns dummy, then numeric calls, comma, access is equal to 1. You can use the same names if you want, but always better to rename separately so that you don't get confused. If at all retrying something or something went wrong, your original data frame remains intact. Otherwise, again, you have to go and split and do it again. So whenever you're doing a major change to the data frame, always give a new name so that your previous version is intact, so that you don't go to the top. You go to the next previous version and then you will do it. Split data into dependent variable, dependent variables. So y is equal to attrition df dot attrition is equal to attrition df dot drop attrition comma axis is equal to 1. Hmm? What sets? Question sets? Yeah, no, same questions, but it will be randomized. It is Google Forms, we can random, right? So each person will get a different question. When we do the questions are same, but it will be randomized. So the order of the questions will change. So the different naive Bayes we have in Python, we have this Gaussian naive Bayes, which implements the Gaussian naive Bayes algorithm for classification. So we will be using Gaussian NB. From sklearn dot neighbors import Gaussian NB. NB is equal to Gaussian NB. NB model is equal to NB dot fit x comma y. The model dot score x comma y. 79.86. LP model. What? For anything, you have to split the data into dependent and independent for any algorithm. So we got accuracy of 79.86. Gaussian means linear naive Bayes. Naive Bayes. Linear, we are doing linear naive Bayes, right? Ours is a linear naive Bayes. We are trying to find the relationship between a dependent variable and multiple independent variables. We can also use Bernoulli naive Bayes, but the independent variables all must be in binary. Pardon? Independent pay prediction, yes. You cannot predict on the dependent variable. It has to be on independent variables only. First only, in the beginning only, 9 o'clock only. So we are creating a confusion matrix here. Confusion matrix is a cross tabulation of actual. What is it? By your actual class. NB predict will also give you predicted class. NB predict will also give you predicted classes, ones and zero. Your actual classes are there, which we have label encoded into 0 and 1. No being 0, 1 being yes. So it's a cross tabulation of these two things. You will get a thing. So it is a confusion matrix. Confusion matrix is a cross tabulation of actual class and predicted class. Of actual class and predicted class. So the actual class is Y. The predicted class is NB predict. It's a 2 by 2 matrix for binary data. It's a 2 by 2 matrix for binary data. So, yeah. So if you remember confusion matrix, 0 and 1, attrition 0 is positive or negative. Attrition 0 means the employee is still with the company. So attrition 0 means no. That means the employee is still with the company, right? With company. Attrition 1 means yes, that means the employee has left the company. Which is positive and which is negative? Which company is positive and left company is negative, right? So 0 is positive, 1 is negative. So true positive is what? 1024. The first quadrant, true positive, right? The second quadrant is false negative. The false negative is 209, which is wrong classification. False positive, again a wrong classification, which is 87. True negative is 150. Got this? Actual class and the predicted class. Actual class is 0, predicted class is also 0, true positive. Actual class is positive, but the predicted class is negative, false negative. Actual class is negative, but the predicted class is positive, which is false positive. And both are negative, actual and predicted class are negative, we got true negative. So you have to find out what is positive and negative, 0 and 1 positive, which is positive and which is negative. And then accordingly, we will decide here. So now using this, you can find out what is positive and what is negative. So 1024 plus 150 divided by all, you will get the accuracy. This is only what you call two predictive classes, right? We have something called multinomial NB. If there are more than 2 levels, we have to use multinomial neighbors. If you are predicting more than 2 classes, we have multinomial NB. So you have multinomial neighbors. When there are more than 2 levels in your data. Gaussian NB, if you are trying to see some of our data are numerical, right? We have numerical data as well as categorical data. We have to use Gaussian NB. Sometimes you will only have categorical data. That time you can use Bernoulli NB. There is something called Bernoulli NB when all your independent variables are categorical in nature. Otherwise, if you have both numerical and categorical, like what we have in our data, we use Gaussian neighbors. We use Gaussian neighbors when we have mixed features, both numerical and non-numerical. Multinomial is used when your dependent variable has more than 2 levels. Got it, all of you? Yesterday's notes I have shared now. Just check. Yesterday, what we did? Yesterday's notes, I didn't email you. Only the notes I have to send, right?